Number 7, find f plus g, f minus g, f times g, and f divided by g for the given functions. State the domain of each function. So in this question, they're asking us to perform function operations on f and g. So let's start with f plus g. F plus g is equal to x plus 1 over x minus 1 plus 1 over x. Now we see that f is a rational function and g is a rational function. And in order to add two rational functions, they have to have the same denominator, just like fractions. So to make these two functions have the same denominator, we can multiply f by the denominator of g, and we can multiply g by the denominator of f. So when we do that, we have x times x plus 1 over x times x minus 1 plus x minus 1 times 1 over x minus 1 times x. Okay, so now we can add them just as we would add two fractions. Leaving the denominator the same. Now, as we can see, we have a lot of parentheses here, so let's get rid of those by using the distributive property. We can distribute our x into x plus 1 and get x squared plus x, and we can distribute the 1 through x minus 1 to get x minus 1. And we still have some like terms in the numerator that we can combine. When we do that, we have x squared plus 2x, because x plus x is 2x, minus 1. So now that there's nothing else we can do, let's go ahead and move on to stating the domain. Now, we see that this is a rational function with a polynomial in the numerator and the denominator, so our only restriction is that our denominator cannot be equal to 0, which means x cannot be equal to 0 or 1. And to express that in interval notation, we just graph 0 and 1 on a number line that goes from negative infinity to infinity. Plot them with open circles since they cannot be included in our domain. And we shade everything that can be included. And from that, we can see that our domain lies on the open interval from negative infinity to 0, from 0 to 1, and from 1 to infinity. Now let's move on to f times g. F minus g, I'm sorry. So for f minus g, we have x plus 1 over x minus 1 minus 1 over x. So it's the same process, but this time we're subtracting the two functions. And since they're rational functions, we have to make them have the same denominator. So we'll do it just like we did the last one. Then we would subtract them just as we would subtract two fractions. Distribute our x through x plus 1, and we get x squared plus x. And we distribute our 1 through x minus 1, and we get x minus 1. But we still have to distribute this invisible negative 1 here. And when we do that, we have x squared plus x minus x plus 1. And we'll leave our denominator factor. Okay? Let's go ahead and combine this x minus x. So we know that x minus x, they're like terms, so we can combine them. And when we do, we get 0, because 1 minus 1 is 0. And that leaves us with x squared minus 1. Okay? So we see that the only restriction that we have is that our denominator cannot be equal to 0. So when we're stating our domain, we know that x cannot be equal to 0 or 1. We graph that on our real number line from negative infinity to infinity. We're just plotting those two numbers with open circles, shading everything that can be included. And from there, we see that our domain lies on the open interval from negative infinity to 0, from 0 to 1, and from 1 to infinity. So let's move on to f times g. So f times g is equal to x plus 1 over x minus 1 times 1 over x. And this is multiplication, so we don't have to make these two fractions have the same denominator. We can just multiply them straight across on the numerator and the denominator. It's not like addition and subtraction. So when we do that, we have x plus 1 times 1, which is x plus 1, and then x minus 1 times x. Okay? So now that we have that, we can go ahead and move on to finding our domain. We see that our only restriction is that our denominator cannot be equal to 0. So when we solve that expression for x, we see that x cannot be equal to 0 and it cannot be equal to 1. So our next step is to graph that expression on a real number line from negative infinity to infinity by plotting those two values and shading everything that can be included. And from there we see that our domain lies on the open interval from negative infinity to 0, from 0 to 1, and from 1 to infinity. Now let's move on to f divided by g. So f over g is going to be equal to x plus 1 over x minus 1 divided by 1 over x. Now when we're dividing two rational functions, we use a rule called keep, change, flip. KCF. It's when we keep our first fraction, or in this case, rational function, we keep it the same. We change our division sign to multiplication, and we flip our second function. And then we can just multiply straight across. And we do that, we get x times x plus 1 over x minus 1 times 1. And we'll distribute our x through x plus 1, and we get x squared plus x. And we'll leave our denominator. We'll factor our 1 since there's not an x. in that second term. So our denominator is going to be equal to x plus 1, x minus 1 after we distribute our 1. Okay, now we can move on to stating the domain. So we see our only restriction is that x minus 1 cannot be equal to 0, which means x cannot be equal to 1. So when we graph that expression, we want to apply x with an open circle because it cannot be included in our domain. We want to shade everything that can be included. And when we do that, we see that our domain lies on the interval from negative infinity to 1 and from 1 to infinity.